So two trains A and B approaching each other on a straight track rather. The former with a uniform velocity of 25 meter per second and other at 15 meter per second. When they are 225 meter apart, brakes are simultaneously applied to both of them. The deceleration given by the brakes to train B increases linearly with time 0.3 meter per second square every second, while train A is giving uniform deceleration. So in this case we are going to find out two things. First is what must be the minimum deceleration to the train A so that the train do not collide, and B is what is the time taken by the train to come to the stop. So let us first draw the basic things which is given. So it is given that there are two trains, train A and train B, and they are moving in same track, okay, and the total distance between them is 225 meter. So velocity of train A is given as 25 meter per second. Velocity of B is given as 15 meter per second, and deceleration of B is given as, it is time dependent, so we are going to write linear rather t. Okay, so these are the some of the things which is given. So next we can write that the distance traveled by the train B, suppose in time t, okay, so we can write that distance traveled by train B, let us call that SB, and that will be equal to 15 multiplied by time t. And similarly we can find out the distance traveled by the train A. Distance traveled by the train A, let us call this SA, and that is will be uniformly decelerated motion. Okay, so we can use the equation of ut minus half et square, as it is uniformly decelerated. Uniformly decelerated. Okay, and also it is given that for train B, okay, so we write this is train B TB, and this is train A TA, train A, and this is train B TB. So for TB, the acceleration B is equal to minus 0.3 t in terms of velocity. Okay, so we can write this as, in terms of velocity, dvb by dt is equal to minus 0.3 t. Now integrating both sides with the respective limits of time as well as velocity. So it starts from 15 and stops at 0. So this will be dvb is equal to minus 0.3 and start from 0 to t dt. So we get this as vb from 15 to 0 is equal to minus 0.3 t square divided by 2 from 0 to t. So these are some simple calculations. We put the limits. This minus cancel out with this minus, so we get t square is equal to 30 divided by 0.3, or this can be written as t square is equal to 100. So from here we find out that t will be equal to 10 seconds. So this is the first part. In the second part, we can write this one as minus of double derivative of distance will be equal to 0.3 t. Okay. We simply substituted the accelerated equation by distance x for b. Okay, for this is okay. We are continuing with train b. Next, what we do, we integrate it first. Okay, so we write it integrating. We are going to get this as this is minus also, I missed it. So we get this as dx by dt will be equal to 0.3 divided by 2 t square plus c1, where c1 is a constant, but we already know that the initial value is given as minus 15. So we put this value, we get dx as dx by dt is equal to 0.15 t and minus 15. So we are going to again integrate it. So let me write this equation again here. Dx by dt is equal to 0.15 t minus 15. So integrating between the distance suppose s1 and s2, integrating. Let us suppose we integrate it for the distance from s1 to s2, dx, and time is from 0 to t, t dt minus 15 dt of time 0 to t. So for the solution, we will get this as s2 minus s1 will be equal to 0.15. I think I missed something. Yeah, I think I made a mistake. Yeah, I made a mistake here. Let me correct it. I missed one part. This is square. Okay, that's one mistake of the part. So square as well as this will be square. Okay, so finally this will be coming as t cube divided by 3 minus 15t so we can write this as s2 minus s1 will be equal to 0.05 t cube minus 15t. So we already know the time taken by train B is 10 seconds. So we can further elaborate it in time t is equal to 10 seconds. The distance traveled by B, the distance traveled by train B will be equal to s2 minus s1 0.05 to 10 cube minus 15 into 10. So this will be coming as 100 meter magnitude, not interested in direction. So it means the distance traveled by train A will be equal to 225 minus 100 and this will be equal to 125 meters. So it means for train A, so we can write this as for train A, VA square minus UA square is equal to 2A SA, and this is our SA. So we get 0 minus 25 whole square 2A 125. So acceleration of A will be equal to minus 625 divided by 2 into 125. So will be given as minus 2.5 meter per second square. Okay, so here negative sign only mean that it will be a decelerated motion. Because of what? Because of the negative sign. Negative sign implies that it will be decelerated motion. Thank you.